positive and negative ions, okay? And we also learned how to do naming of binary ionic compounds, also writing them, right? Now today what we're going to do, we're going to do the dot structures for binary ionic compounds, okay? Now remember, we did those videos before, so I'll probably put them in the description so you can look at them. I'm jumping to the rules and the way that we do the dot structures, okay? All right, so what we're doing, dot structures, okay, for binary, all right, ionic compounds. Now this is very, very, very simple, guys, all right? But as they always say, right, chemistry is foundational. When they give you to do the dot structure, they're not going to tell you this compound is ionic, this compound is covalent, right? You have to know. So we know from experience, right, the best way to recognize a ionic compound is made up of metal and non-metal, all right? Now once again, how do you know metal from non-metal? That's covered in the topic of periodic table, right? So, you know, just review your notes, okay, and make sure you know metals from non-metals. And when you see them together, definitely that's going to be an ionic compound. So, let's say they say, draw the dot structure, okay, for, I'm making up something off the top of my head, lithium. All right. Lithium fluoride. All righty. Okay. So we know lithium, right, is made of a metal ion, okay, when it's in the compound, and fluoride is made of a non-metal negative ion, right? So we get a positive and negative ion, you have a metal and a non-metal, okay, here, combined, we know it's ionic. So we got to use a couple of things, alrighty? Now remember from our previous video on dot structures, okay, the positive ion, right, once again gets no dots, alright? Because remember, metals lose that valence electron, okay? And we're representing the fact that it's an empty shell. So all you do for lithium, right, you put a bracket down, alright? You put your Li, alright? You put your other bracket, you put your +1. Now guys, the formulas and the symbols for these guys are on your reference table, periodic table. If you're not sure what they are, look on table S, the symbols are there. Don't make up a symbol, alright? Also, you can figure out the charges. Lithium has one valence electron, it loses it, okay? It forms a +1 ion. Also, if you look at the box for lithium on the periodic table in group 1, you'll see the +1 there. So we're not making up charges, but the charges are very, very important. Alright, now fluoride, right, is a negative non-metal fluorine ion, right? Okay, fluoride ion, so no problems. You put your bracket as before, you put your F, alright, okay, that's your kernel, and you put 8 dots around it, okay, and don't forget your charge, bam, alright, and you're done. That's lithium fluoride. Now, when you're doing your dot structures, your charges must be balanced, people. Now, this is a nice 1-to-1 ratio, charges are balanced, right? But let's do another example where your charges are not balanced. Okay, so let's do something like aluminum sulfide. So, aluminum sulfide. Let's do L-F-I-D-E, boom. Alrighty? Okay. Now, what you gotta do, you have to understand, right? Aluminum is a metal, M. Sulfide is a non-metal, okay? And M there for non-metal. You form positive ions, negative ions. So you gotta do dot structure, you gotta use your brackets, your charge, and so on, right? So get your formula first. You need to get your correct formula. So we know aluminum, right? Look on your reference table, forms a +3 ion, okay? Sulfur forms a -2 ion. Now once again, review your notes, review that video on naming and writing compounds. We're using here the crisscross method to get the correct formula, right? So when we crisscross, okay, we're going to get the 2 going to the subscript of the Al, and we're going to get the 3 going to the subscript of the S, right? So what we're going to get as the formula, correct formula, Al2S3. Okay? Because once again, they can give you the name and ask you for the dot structure. You got to get a correct formula first, and then you get apply and get your dot structure from there. All right. represented. Now, how do you represent that? You use coefficients. All right, so here you do. You put your Al down. Now remember, Al is your metal positive ion, right? Gets no dots, right? Now you look on your reference table, as we know before, it forms a +3 ion. Now very carefully, right? The fact that we have a 2 here, okay, Al2, you put a 2 in front here as a coefficient, okay? Representing you got 2 Als. So this subscript here in the formula becomes a coefficient here, okay? 2 Als at a +3 charge. Same concept for the S's. The S is your non-metal negative ion. It has 8 dots, alrighty, around it. It has brackets around it, alright? And it has a -2 charge, right? But what you have to do, okay, you have to make sure that you have a 3 in front of it, which I forgot to put, leave some space for. So I'll do that. You gotta put a 3 in front of it. Where does that 3 come from? I got a 3 here, representing I have 3 S's. So I gotta put a 3 in front of the sulfide ion. So I got 2 Al, 3 S. 2 Als here, 3 S's there, and you're done. So dust structures, guys, are very, very easy for ionic compounds. So what are the steps? Okay, step number 1 is get your correct, alright, formula, if they give you the name. Alright, sometimes they give you the formula, no problem, but if they give you the name, you gotta get a correct formula, right? Okay, and use the rules for the positive ions that we learned before, and for the negative ions, okay? And rule number 3, if you have subscripts, right? Subscripts. Okay, you represent the subscripts as coefficients, okay, in the overall dot structure, and you're done, okay? No problem. So this is a nice short video on the ionic dust structures. Once again, metal, non-metal means it's ionic. If it's non-metal only, it's covalent. Don't mix and match, okay? Because covalent dot structures have their own unique way of doing things, different rules, okay? No problem. As always, hard work plus sacrifice equals success. Take care, guys. All right.